There are many work holding devices used on milling machines. The most common one is a vise. A milling machine vise is different than a drill press vise in that it is more precise. The vise is actually made to be parallel, so this part of the vise inside the jaws is parallel to the base of the vise. So that's very important for precision. So whenever you put a vise on a machine, it's very important to make sure that the table is clean. Always start with a rag, and after you have it wiped off with a rag, I'd like to use my hand. If I rub that with my hand, I can feel any dirt on the table. If you're using a rag you can't feel the dirt. So once you have it free of burrs and chips, make sure there is no dirt on the table. The other thing you can do with your hand is when you're running it on the table like that, you'll feel any deviations in the table. If somebody was doing a tool change and they took this cutter out of the machine and they dropped it on the table, that would put a dent in the table. Around that dent is actually a high spot. So if you want to think of it as a teeny tiny volcano, the dent is actually the hole in the table, but around that hole would be a high spot around that crater. So whenever you mount a vise onto a machine, it's very important to hone the table. Go over it with the core stone first, right in the spot of where you feel that in the table. You just want to work that around in a circular motion. It kind of scrubs the table, they call that. So if you're ever asked to scrub a table with a stone, this is what they mean, or they'll call it stoning the table. It doesn't take a lot of pressure, just kind of go over the table quickly and make sure that there is no defects above the surface of the table. After you're done with that, use the fine side of the stone and just make sure there are no high spots on this table. When this table was made, it was very precise and very flat. Over the conditions of using it and everything else, there gets to be little defects in the table. So the best we can do is remove the high spot. That low spot is always there. So after you do the table, you just got to do the area where the vise is going to be sitting. You don't have to do the whole table. It's not a bad idea to do the whole table if you have that opportunity, but you don't have to. You also want to check the bottom of your vise, because very commonly these vices, they're very heavy. They're 50, 60 pound vices. So when you pick them up and set them down on different workbenches, it seems that they set them down hard, or they might set it on something once. So you want to just check the bottom of your vise as well. Just simply stand your vise up on the table and don't let go of it. Keep a hand on it because you don't want it to fall on the floor. And take your stone and actually stone the bottom of the vise as well. Make sure there's no high spots on the bottom of the vise. So there are two. Use the coarse and the fine stone. So the best way to be precise in the machine shop is to be very clean and make sure your setup is free of defects. So once again, I'm going over it with my hand just to make sure there is no defects. I'm going to go over the bottom of the vise with my hand and make sure it's clean and free of defects. And I'm going to put the vise flat down on the table. I'm going to slide it into position. Most commonly here at school, we put the vise in the middle of the table. There are times when you want to use the table for something else, so you may set the vise up off center. So you could leave your vise on and then do a table setup next to it. But like I say, very commonly the vise is in the middle of the table. So when you set the vise on the table, there's these slots in the vise that are going to line up with the slots in the machine. The slots in the table are called T-slots. There's a special nut that goes inside the T-slot, and it's called a T-nut. So the T-nut goes down inside the T-slot. Then there's the stud and a washer and another nut. So this nut on top and the washer. So this stud is threaded all the way along both ends. So you put the T-nut down inside the table. You put the washer on and then the nut. You need one for each side. So a lot of people, when they put the vise on the table, they just feel down inside with their fingers. You can get it pretty close to straight. That's what we're trying to do here. When we put the vise on the table, we want to make sure the vise is straight to the machine. So I'm going to start out just by feeling inside the grooves to make sure it's lined up and somewhat centered. That'll get you close. And go ahead and slide the stud, the nut, washer, and T-nut assembly. Up to the vise. And just finger tighten them for right now. Both sides are just finger tight. The next thing you want to do is take a 7/8 wrench and you just want to tighten the one nut a little bit. Don't have to be too tight because we still got to be able to move the vise. So just tighten it up a little bit. So with this side snug and this side loose, when I go to square up the vise now, this will act as a pivot point. If you didn't do that, if you had both sides loose and you try to indicate this vise in, it's going to be moving everywhere and you're going to have a really hard time getting that centered on the table. So just take the wrench and tighten up one side. Not too tight. You want to be able to move it yet, but you want to have a predictable pivot point. So if this side is tighter than this side, it will pivot around this bolt and this side will slide back and forth. So now we need to be able to take a reading along that vise. We want to see how straight is it to the machine. We're going to use the same indicator that we used when we squared up the head to the table. So 5/16 collet again. Need your indicator, put it into your indicator holder. There's various different types of indicator holders out there. This is the kind we have. There's other ones in the drawer as well. You can pretty much use anything you want for that. Some people have different ones that clamp around the outside of the spindle. There are other ones that look more like a cantilever arm. This one was actually a student project that we made here, so we have the most of these around right now. We need to lower the table. What we have to do here is get the contact tip of this indicator inside this back jaw of the vise. Now when you use this type of indicator on this machine, you want only the ball to touch along that vise. So I'm just going to touch it right here on this edge, just until it says 0 on the indicator again. Now I'm going to move the table down and actually see how straight this vise is to the machine. So as I move the x-axis, I'm going to check if this jaw is parallel to the x-axis. That's what we're looking to do. We'd like to see that within 1/1000th of an inch over the width of the vise. The reason why we indicate in on the back jaw is the front jaw is the movable jaw. So this jaw is actually the one that opens and closes. So if this jaw is a moving jaw, it's not reliable to indicate on because it's actually loose on the machine. So you want to indicate in on the solid rear jaw. So I got my indicator touching at 0. I'm just going to go to the other end and see where it's at. My indicator went counterclockwise, which means it's not even touching on this side anymore. It went away from 0. And you can actually see the airspace in there, just like we showed before. You can see the airspace between the vise and the indicator. So what it's saying is that that rear jaw is back too far. So knowing this is my pivot point, and I was 0 here, I should be able to move the vise towards me, or push the tail end of the vise that way. So if I push on it here, it should rotate around this bolt. And you'll actually see the indicator jump. I'm just going to start out by zeroing this side. Since the pivot point is outside of here, and I zeroed it here, chances are my 0 is moving as well. So I'm going to go back to 0 now and just see where it's at. Just as I suspected, my 0 did move. It says it's positive 0.03 now. So I'm just going to move the table to return to 0, go back to the other end, and we'll check it again. Now it says it's within 0.03 and I still have to go this way. So before I went a certain amount and it wasn't quite enough because the pivot point's out here. So I'm going to go just a little bit past 0, maybe 0.5. Now we're going to go back to 0, and my 0 moved about 0.5 as well. So I'm just going to re-zero that. So I'm looking for 0, 0 all the way across. Look at that, it's within probably 0.0001. It's probably within 1/10,000th of an inch right now. So now I'm going to snug up this side equal to this side. I'm going to go back to this side and snug this one a little further. And I'm going to finish tightening this one. Whenever you tighten down bolts on a table, you want to work them evenly. It's the way to keep the vise square and uniform, so when you tighten it down, it stays where it needs to be. After you tighten up the vise, just double check it one more time. It's perfect. So that's how you indicate in a vise. Like I say, the vise is the most common work holding technique that we use. There's no reason why you can't use different devices. There's angle plates, there's rotary tables. You can do a setup right on the table and clamp your parts right to the table. But the vise is the most commonly used one. The next thing I'd like to talk about is a couple of the different work holding devices or tool holding devices that we use. Some of the tool holding devices we use are collets, drill chucks, and solid holders. This is actually a shell mill arbor, and that holds onto this face mill. So this has to be, it's a one-piece assembly. This does not fit in a collet. The types of cutting tools we use are drills, end mills, and face mills. A face mill does exactly what it's called. It faces off of a part. So this will go up in the spindle like that. Then as you traverse across a piece of material, it'll machine the top of the material off, or machines the face. An end mill is sharp on the end and around the outside edge, so be very careful when you handle end mills. It's razor sharp all the way around. And these could be used for face milling as well. You could use the end of this to face mill. You could also use the side of the cutter to mill an edge of a part. And they also work really good for going inside of a slot. Remember, end mills go in a collet. I have some students try to put end mills in a drill chuck, and that's the incorrect setup. You need the end mills to be in a collet or an end mill holder. Drills. Drills will go in a drill chuck. Now the drill chuck, you'll notice, will have the same kind of taper on there. It's called the R8 taper, and it has that key, just like the collet does and the face mill has. So you always want to make sure that key lines up with the machine. I think everybody has used a drill chuck. If you've seen a drill press before, you've used drill chucks. As you rotate the outside collar, the jaws open and close, and that is used to hold onto a drill. There's also the drill wrench, or the key, the chuck key. And that's what you use to tighten up your tools. So I'll demonstrate that all further as we go through different processes here on the mill, but I want you to be aware of the different tools that we use. The tools are almost always stored on the side of the machine, unless the students don't put them away. The cutting tools will be in a drawer over there in their proper location. The collets should be on the machine. Every machine should have a full set of collets. When the vise is on the table, one thing we like to do too is use these tool boards. We put the tool boards on the table to protect the table. Just like I told you when we put the vise on the table, we want to make sure this table stays nice. We don't want to be dropping things on the table. These cutting tools are designed to cut metal. So if I set this on the table or set it on the vise, I'm actually kind of losing the integrity of that surface by laying cutting tools on there. So you want to use a tool board. If you want to lay your tools down on a table, use the tool board. Even hammers, files, wrenches, everything, put them on a tool board. We want to keep this table as nice as we can keep it. That pretty much concludes this video. We talked about the different cutting tools we're going to be using in the next couple demonstrations. But always make sure that your vise is clean, your table is clean, and everything is nice and square.